Hello guys and welcome to another video. Today we will be discussing about linked lists in Java. Linked list is a type of data structure where we store data within nodes. It is almost similar to arrays in representation, but the main difference between arrays and linked lists is that linked list does not follow contiguous memory, which means the data is stored at random places within that memory. The best way to explain linked list to you would be by showing you some visual representation of linked list. So if I just show you something, let's say if this is an example of a linked list. This is a singly linked list or a single linked list, which means it only has a single address that points to the next pointer. So this address or the value that says address within this is the one that points to a next address where the second data is stored. For example, if I say this data is stored at the 1000th location, this could be stored at 1064. So it does not have any match, which means it does not follow contiguous memory like arrays. A linked list has a node, for example. A node is nothing but a box that has two fields, that is the data field and the address field. The address field acts as a pointer to the next node, and the data field stores some specific data within that linked list. So as I have explained, a linked list does not store data within contiguous memory. So to access that data, we use this address field, which acts as this continuous sequential location to different nodes stored in different locations. And the last node within that single linked list, which is this, does not have an address field. Instead, it just has a null value in that address field. And to easily explain the representation, we actually use a pointer to start a single linked list. So this is a first pointer which starts the single linked list. There are different types of linked lists in theory in data structures. Like for example, this is just a single linked list. You can also see a double linked list. So if I show an representation, this is a double linked list. So let's just say this is a double linked list. So if I say, you can see the difference already within that representation. It has two address fields, which means it points backwards and also forwards, which makes it easier to access. The main problem with single linked lists is retrieving data. So you can't really go back within a linked list. You can only go forward to the next address. So to fix that problem, we use double linked list where we can go both ways. So we can go backwards and forwards. Generally, if you see the C program implementation, we can see that these are generally called the next pointers. So if I say, and if I just say it's called the next pointer, so the next pointer goes to that next node. And for double linked list, the next pointer is the same, but the other pointer is called the previous pointer. So let's just say that similar to that. So it's just a previous pointer. There are also many other linked lists within theory of data structures. So there's also linked list like the circular linked list where, so if I show you a basic example, I can just say, here we see that there is a null value at the last node. Instead, in a circle linked list, it's completely different where it acts as, it goes back to this pointer. So this is what happens. Excuse my drawing, but the last pointer or the last address field actually becomes active. So what it does is, you can just see it becomes an address field again. So this address field again points to this first pointer. So what happens in the circular linked list is it creates a loop of that linked list where you can constantly go to the next location and there is normally no end. We generally use circular linked list to visualize or create a method similar to that of a queue where the data gets constantly pushed at the head and is removed from the tail, for example. It's just a basic example or a comparison, so don't take it too serious, but I just want to explain it to you in an easier way. So similarly, we also have a circular linked list or a double circular linked list. So I don't really want to show that because it's similar to this. So let's just go directly to the code where we implement linked lists in Java. So if I come to the program now, let's just take some space. And now the main part is the import statement. Again, I say this again and again because without the import statement, you generally can't really create these linked lists because these import statements help us create or bring out a template that is already present within Java. So the linked list cannot be created without this template or this class that we are bringing in from the util class. So just don't forget the import class. Or if you are using Visual Studio Code as your IDE, you generally, as soon as you type the linked list, generally imports it for you if you have the correct extensions. So just make sure that the import statements is correct and you can start programming. So let's just start. It is similar to that of an array list. If you have watched my previous video, you will understand what I'm trying to say. So if I create a linked list now, let's just say again, I want to create a linked list that stores, let's say, string. If I can just call it names, and if I just say new, again, linked list and a semicolon. So we have now created a linked list that stores values of the type string, and it is called as names. So again, I want to test it out if it actually has been created or not. So if I just print out and let's say the names, and if I run this program, you can see that it is empty right now. But yes, we have actually created an empty string or an empty linked list of the type string. So what I'm trying to explain to you here, or the main part within creating these similar to ArrayList, is the data type. Within these less than and greater than symbols, we need to type the data type correctly, and we need to make sure that we actually follow that data type when we're adding values. So I want to add values. This is also similar to that of an array list. So all we need to do is type in names dot. Again, if I just say add, and if take strings, so if I add, let's say, the name John, for example, and if I run the program now, we can see that the value John has been added. So let's just populate this linked list for, let's just check it out. We can store as many values as we want. So let's just say Smith. Let's just say, for example, Paula, for example. And if I run the program again, you can see that we see, actually, let's make it bigger. So we can see the output where we have created a linked list that stores John, Pollard, and Smith. So here we have easily implemented linked list within Java without actually implementing the fundamental code of a linked list. That is because we are using this util class and we're bringing in the template for a linked list. So if you read this, you can understand why I'm trying to explain to you how data lists or how data structures are easier in Java than in C. So it obviously similar to that of ArrayList, we actually see other methods. Let's say remove, and if I just say, I can just give a value or an index. So if I give, actually I can just give a value. Let's say I'll remove the word Pollard. Let's check it out, and it actually removes that from that linked list. So these are the methods that you can work with, and there's also methods that I want to show you, like let's say addLast is another method where you can add an element at the last. So if I just create another name, if I just say James, for example, and there's also another method that I want to talk about, which is addFirst or addFirst. Let's say again a string. Let's just say Harry. So again, if I run the program now, we can see that the addFirst method adds this value at the start, that is Harry, and the last method adds this value at James. So again, normally you won't really use the addLast method because whenever you actually add it, it generally ends up at the end of the linked list. So I don't normally use that addLast method. Generally, you can use addFirst to add an element at the first. So let's check it out. Now let's just see other methods. Let's say names dot remove all, which is again, you can do that. Let's just check it out. Remove first, for example. So if I try this, we are trying to remove the first value. So we have removed Harry, the name which we have added at first. So we just added first and then also removed first. Again, similar to that, we also have removeLast. So we can just do this, and so we just remove the last name, which is James. So these are all the methods that you generally use in linked lists or to implement linked lists with Java. You can try it out by giving a user-defined values, like creating a linked list of some specific size or some specific data type, and then you can give out user-defined values by using the scanner class. I'm not going to do that. You can try it on your own, and you actually understand some code whenever you try it on your own. And every time you get an error, I think it's just a choice or an opportunity to learn something new. So another thing that I want to discuss with you would be how we can imitate a queue within a linked list. So if I write a command here, I can say imitating, let's say, a queue using a linked list. So we can do that by, let's just create another linked list. For example, here, I'm going to create another one. Let's say this. I'm saying this because generally to implement queues or the queue data structure within Java, we generally use the linked list or the priority queue class, which is this. After util, we generally don't have a direct queue value, or a queue class. So we use linked list, or we also use the priority queue to implement a general or a basic queue. So I just want to show you a basic example. So I can just say names to dot. I need to use the method offer. So I just can do this. Let's just say again, add the name, some random name. And if I just print out names flew, I can do this. And now if I run the program, let me just clear this terminal for now. And just if I run the program, you can see that this is now a linked list that acts as a queue. So what I'm trying to say is it inserts values at the end and deletes the values from the front. So again, if I do the same thing, for example, I just want to repeat this for a few. I want to populate this linked list. And again, if I just do some random name, again, let's just use the same names. I can say, I don't know, Toby, for example. Now, if I see this, let's just check out if it actually works. Wireless spaces. Let me just remove the spaces so that it makes it easier. And if I just run the program now, again, we have 3 names here. So I want to try and remove from these names 2 linked lists, for example, let's say. And if I just remove the name, for example, let's try actually what the remove value itself does. So if I run the program, you can see that it removes the first value, that is the James. So without even mentioning any type of value itself or an index or location for that matter of a linked list, it generally removes the first value. So as you know, in a queue, the values are removed at the start and the values are added at the end. So this is the way to imitate or show a queue within linked list. So again, we will discuss this in the queues data structure video. So I don't want to go deep into this, but I just want to show you there is a technique to do this, or there is a technique to actually implement this easily. So that's it for this video. So please try to like and share and subscribe to this channel, and also make sure that you turn on the bell icon for more videos that are coming about data structures in Java. And I hope that you have understood the concept of linked lists in Java, and see you in the next one.